Okay, did anyone have any questions from last day's work? Are we not getting announcements today? Okay, a reminder that your quiz is on Monday. What sections is it on? 2.1 and 2.2. Okay. And we didn't have any questions from the homework. We were good with that? Okay. So last day we had just started looking at situations where we are not yet at equilibrium. This was on page 96. And we had just looked at a rice table. And I did not, because it was quite close to the end, I don't think I got to stress as much as I might have. Well, where is everybody? Yeah, where is everybody? Anyway, I don't think I got as much as chance to stress that these changes.
Please excuse the interruption. We are asking the grade 9 students only with the last name, the letter S. Please go to the library for your immunization if you haven't had it. Last name beginning with the letter S, grade 9 only. Please go to the library for your immunization if you have not yet had it. Thank you.
Okay, so the change, that is the shift. And just like on our concentration graphs, your shifts go up or down by x or 2x or 3x. These are similar. They are proportional to the coefficients. Yes? Because every time you make one chloride, you make two NOs. So it should make sense that the change in concentration, you make twice as much NO as you do Cl. Okay, so just remember that when you're looking at the changes in your rice table, it's always going to be proportional to the coefficients, right? Okay, the rice table is the accepted way of showing work for any questions where you have both initial and equilibrium conditions. If you're just at equilibrium, then just chuck the numbers in and don't use a rice table. But if you are not at equilibrium, then you're going to use a rice table because we've got that I for initial and E for equilibrium. Kata, could you shut the door for us, please? It's noisy out in the hallway. Thank you so much. Writing the rice table. It is worth 1 to 2 marks in any question that has initial and equilibrium condition. It can be worth up to half the marks awarded in a question. You must include the rice table or you will lose marks. Yes? So don't leave out rice.
I'm supposed to do rice without writing rice.
Some people just go straight to they do it in their head, and then they just chuck the numbers in. Yeah? But you should show your work this way, okay? Okay, we now have 4 moles of ICL is placed in a 1 liter flask. And is allowed to come to equilibrium. Anytime you have something that is placed in a flask, that means those are your initial. This question doesn't say initially, but you can assume that when you place something in, you're putting it in there at the beginning, okay? Anytime you see is allowed to come to equilibrium, that means you're going to use a rice table, okay? It is found that the equilibrium mixture contains 106.5 grams of Cl2. Calculate the KEQ. Well, how do we know we're not yet at equilibrium? Because it says we are allowed to come to equilibrium, okay? So when we have our rice table, last time we actually wrote initial concentration, change in concentration, equilibrium concentration. That gets exhausting. So if you choose to, instead, you can simply write I in square brackets, C in square brackets, E in square brackets, because that means our initial concentration, change in concentration, and our equilibrium concentration. Do you guys think you could fill in the rice table? Give it a try. You may need to calculate some of the moles per liter because remember, everything in this table has to be in moles per liter.
Cl2 is 35.5, right?
Yes. Oh, no.
One Cl.
1 Cl is 35.5, yes.
So Cl2 is just 2. I mean, moles. Does that make sense?
What? No.
It's the ratio.
Uh-huh.
So it's 4 is ICO.
Okay, so we have 4 moles of ICL is placed in a 1 liter flask. So that's pretty straightforward, yes? So we have, and I like drawing lines. You don't have to draw lines. I like drawing the lines. Keeps my brain organized.
Please excuse interruption. We are calling grade 9 students only with the last name beginning with the letter T, U, and V. Please go to the library for your immunization if you have not yet had it. Grade 9 only, last name beginning with the letter T, U, V. Please go to the library for your immunization if you have not yet had it. Thank you.
Oh.
And that would have just been fine, not it's good so far. Yeah, yes. When you're doing it for a showdown.
Well, definitely.
Okay, yeah, yeah. But you don't want to. Oh, this has some or it's yeah, it's just it's kind of one, but usually this is correct. That means now, say the constitution of chloride, chlorine is that in moles in 1 liter. Okay, but in your, that's the one you got. This one. This is CL yes, yeah. Because you guys put the 2 atoms in the molecule. It is. Yeah. Look at that here. Other coefficients, yeah, no, you want your concentrations. No, no. And you get the want moles per concentration. Okay, it is 1 liter of gas.
Well, in this 35.5 times 2, that's 1.5 of y. No, because if you're just one CL is 35.5, and you have to keep. Yeah, so that's 1.3.
And that's actually, so that's gonna be down in like. Still going over. And then those would be right.
And one of these.
So whenever you're doing this, remember your unit in here has to be molar. What does molar stand for? Molar stands for moles per liter. In this case, it's really straightforward because we have a 1 liter flask. So whatever moles we have will be the same as the molarity. I do want you to watch out for Cl2. Should this number be 35.5 grams? No, because it is Cl2, it should be 35.5 times 2, which is 71.
It cancels out there.
Does it? What do we get?
1.5.
Oh, 1.5. That's nice. Now, A lot of you I'm seeing are just putting 1.5 in there. I would keep my sig figs. I'd say, I need 3 sig figs. So I'm going to have 1.50. So over here, that's going to be 1.50. We only put ICl in there. So what are the concentrations of I2 and Cl2 initially? 0. And when you know one on the top and you know one on the bottom, you can figure out the change. That one had to go up by 1.50. What did I2 go up by? 1.50. How did I know that I2 was a plus sign?
No, it's because like you draw the up arrow and then it goes up. It's shifting right.
It's shifting right. It has to be shifting right because if I start with 0, I can't go to a negative concentration, right? I have to be shifting towards the products. So those two have to be going up during the shift. So that's going to be 1.50. Is the ICl change also going to be 1.50?
It's actually going to be minus 3.
No, it's going to be 3. Do I just leave it as 3? No, it should be 3.00 because that's going to allow me, and is it going up or down? It's going down because we're shifting to the right. We're using up reactants and we're making products. So we get 1.00. And then I actually did not show my work very well down here. What did I do wrong down here? If I were showing my work, I would have to say moles. If you're dividing by 1 liter, I'm not going to get wound up about you showing the work for dividing by 1 liter. Do you know what I mean? But if it's dividing by 5 liters, I would show it, you know, because that makes more sense. You have a question? Yes. No. No. Okay? They just end up being what they are. And then if we want to calculate KEQ, we have to write KEQ equals, and we have to write our KEQ expression, I2 Cl2 over ICl squared. And we have 1.50 squared over 1. And that's 1.00. So I have 3 sig figs, 3 sig figs, 3 sig figs, and that is 2.25, and we are done. Is good? Okay. So that's how you calculate KEQ. We might, however, ask you to do something different. Oh, just before we go into that, anytime you have only reactants or only products placed in a reaction vessel, say like a flask, you know that the system is not yet at equilibrium. And if it's not at equilibrium, what should you be using? Rice. So anytime you have blah, blah, blah is placed in the container, you're like, rice. Yes? Anytime you see the words allowed to come to equilibrium, or even if the word equilibrium isn't mentioned, allowed to react, that also tells you that you are not yet at equilibrium and that you are going to use rice. Here we have a new kind of question. We've been finding KEQ up until now. Do you see how we have reactants only? Are placed, that tells us rice. It also says allowed to come to equilibrium, rice. So you've got two confirmations that this is a rice type problem. This is a little bit different though, because we have given you the KEQ and you are asked for the equilibrium concentration of NO. That's our unknown there. Could you please set up your rice table? I haven't given it to you this time. Set up your own rice table this time. Where are my scissors? I'll find that. We're running into unknowns. Mm-hmm. How did we do with getting our initial line of our table? Yeah. So we took our concentration of N2 initially is the same as the concentration of O2 initially, which is 2.00 moles divided by 2.00 liters, which gives us 1.00 molar. So we can fill those in there. And because those were placed in there and we didn't say anything about the NO, there's no NO at the start. Now we run into problems because up till this point, we've had an equilibrium and we've been able to figure out the change. When you were graphing and you had to show a shift and you didn't know the amount of the change, what did you call it? When you were graphing and you didn't know the amount of the change, the shift, you didn't know the height, what did you call it? X. So what you're going to do is you're going to say, well, we have to be shifting to the right. Yes, because we don't have anything there. So this has to go up. This has to go down. This has to go down. If we have an unknown, what could we put in for the unknown? X. Are we happy with my X's?
Yep, let's do that.
Is the first X okay? Yeah. Second X okay? Yeah. Third X? No, because we've got this 2 here. It needs to go up by 2X. Okay, because there was 1 here. Every 1 O2 will give you 2 NOs. All right, and now what we get is we get 1.00. It's really tempting to just write 1 minus X. Don't do that. Keep your sig figs there so you don't get messed up with them later. Okay. 1.00 minus X, 1.00 minus X, 2X. And once again, you're going to write your KEQ expression. KEQ equals, I'm starting to see some people do this. Is that the KEQ expression? No, that's the general formula, but anytime you write it, you need to put in the actual chemicals. You can write that if you want to, but it's totally optional. What you need to write is you need to write that you have NO squared over N2 times O2. And then we're just going to plug everything in. So our KEQ is 4.51 times 10 to the minus 3. And our NO is 2X and then our N2 is 1.00 minus X, and our O2 is also 1.00 minus X. Are we happy with what I've written there? What have I forgotten? I have forgotten my square. So should I just do that? No, I have to put brackets around it. Okay. Now, I've written it out this way because I just wanted you to see everything in there, but I could just as easily have written this as 2X squared over 1.00 minus X squared. And I will let you in on a little secret. For grade 12 chemistry, you do not need to do any quadratic equations. Okay? No X equals minus B plus or minus root of B squared minus 4AC all over 2A. Anyway, you don't have to do that because they're always going to give you an out. All right, and in this case, the out is that you can just take the square root of the whole darn thing because everything is squared. You take the square root here, you take the square root there, and so we will get whatever the square root is, 4.51 times 10 to the minus 3. Square rooted is 0.06716. And that is equal to 2x over 1.0 minus x. Is that correct?
How do you know the 6 squared?
How do I know? I don't. I'm going to keep the entire number in my calculator. Keep entire number in calculator. I will often write down, now in the end, I'm going to need 3 sig figs. Yes, in the end, I will need 3 sig figs.
Please excuse the interruption. We are now calling the last of the grade 9 students with the last name starting with W, Y, and Z to head to the library for your immunization if you have not yet received them. Grade 9s only, last name W, Y, and Z. Please go to the library for your immunization if you have not already had them. Thank you.
Good Lord. Okay. You don't need to show this much detail with like showing your work for the algebra of it, but I'm going to show everything because sometimes I'll get people going like, where did that number come from? So I'm showing you where the numbers came from. What I'm doing is I'm taking this and I'm bopping it up here, and then I multiply through 0.06716 x, 2x. I like having my x's on the left-hand side. So I'm going to move all my x's over to the left-hand side. So that's going to be 2. Tell me if you don't know where I got this number from. 2.06716x. Do we know where I got that number from?
Subtracted. Wait, no, wait.
Okay, so what I did is I moved the 2x over to the left, and then I moved this guy. I kept that guy. Well, actually, no, I flipped the entire thing. So what I did is I said 2x is equal to 0.06716 minus 0.06716x. Yes? But that's exhausting. So I just did all that in my head, and then I added this to the other side. So I now have 2x plus 0.06716x is equal to 0.06716, which gives me 2.06716x is equal to 0.06716 x. No x, just no x there. I got carried away. And then x is equal to 0.06716 divided by 2.06716. And we get, good Lord.
0.325.
Okay, so divided by 2.06716 equals 0.032487. Whew. You don't need to show all of that work. If you're like, I do not need to show all that work and I can still get to X and I will get it correct, that's fine. Yes? But if you go wrong, if you're a person who tends to go wrong in their algebra, show as much work as you need to not go wrong in your algebra. Okay? I would never show this much work. That would drive me crazy. But anyway. Now, we have to ask ourselves, is X what we wanted? Let's go find out. We wanted the equilibrium concentration of NO. What is the equilibrium concentration of NO? Look at your rice table. It is 2x. So we're going to finish this off. Our concentration of NO at equilibrium is equal to 2x, which is equal to 2 times 0.32. I'm going to write 0.325. Am I going to round that off, or am I going to keep the whole number in my calculator? Keep number in Calculator. Do not round off, but I don't want to write all those digits. That's a pain in the butt. Yes? I've got on my calculator, it says 0.032487341. So I'm going to take that entire thing, unrounded, and press times 2. Okay? And then I get 0.064974. And I've run out of room, which is too bad. Fortunately for me, I can just go on to the next page. I'm going to round that off now to my 3 sig figs, 0.06. What do I get? 50. And then molar, because it is a concentration. So you're going to complete these on your own sheet of paper. So if you do not have your own sheet of paper, you are going to go get one from back here. Okay? Come help yourself with paper. If you have your own worksheet, work paper, use that. If not, you're going to do that. And let's have you do this entire page. Why not? 1, 2, 3, 4. There's only 4 questions. That's pretty good.
Can you go back to the right?
Yes.
We just replace all the X's with.
No, you just leave it like that because you're solving for 2x at the end.
By 2 and then these are going to be the same.
Yeah, so NO is 2x.
Yeah.
Yeah. So we take our value that we got for x, we multiply it by 2, and we get our final answer. Yeah?
We still haven't calculated EQM.
EQ what?
Oh no, we still haven't. Oh.
We haven't been asked for that. We were asked for equilibrium concentration of NO. Yeah? Got a little bit of work time now, yeah. Nice. So you're into where? What? Which one to go to? What's happening? That's what I'm saying. Which ones you got into UBC? What's the now? UBC. Okay. Then you're like, I have no idea who want to be at. That's a pretty cool place to be. I lived there for 8 months. There's a lot of research opportunities. That's what I've heard.
That's why I'm like interested.
Yeah. That's what I thought.
Most people
Uh-huh. Yeah. Yeah.
Really, I think it's, you know what I'm saying, like it's not
What, sorry?
it's not as harsh,
Yes.
especially when it comes to creating.
Oh, yeah. Yeah. Which is kind of nice. Like harsh. Harsh is not amazing. No.
Yeah. Yo. Ready. That's correct.
This letter is. It's like. Yeah, it's really pretty. Oh, you know what? Where's the, wait. Production and stuff, actually this. Yeah, right there. Oh, it's still this one. I do a house.
Like, you, the thing that you.
It's like this. Go. If I figure it's time for you to go. Yeah. No, I do. Okay. So.
Yeah.
So what figure out about that?
Okay.
So action?
Yeah.
If she does, not really. Right? It says, it did the infant, this. This. So.
Right, I'm in the right way.
Now you take it just.
Question what it says about the CL2. It says when equilibrium is a mean, it is bounded. Yes. Oh, yes. They're all same. Oh, and did you get to see your test?
Oh,
Okay.
Unless you don't consider problems the ball. There's socks where your toes go into each one has a little pad. Yeah, it is kind of weird, but like. They're like lobster in your feet. That's all those socks are. In fact, there's socks that like toes. Right? I just wonder how I Oh, so she really used that. People that I know there was that
Additional console, I think, writer.
Unless it's a,
Oh, I
so she can hear it clearly.
Yeah. Oh, okay, that's what, yeah. I didn't know that. You're kind of, I didn't, I'm not. That makes a lot of sense though, because the company is not saying. Yeah.
Yeah. No, but there was your class, the very last, I mean, it was like.
I think it was that.
Okay. Oh, I do.
What do you think?
But it's not.
Next thing I feel it. I think it's just gonna be too. Relax. Is there any straight geometry? Or concentration stoichiometry? Right? Yeah, 2 to 1 to 0. Yeah. 1 to 1. There's this, but then there's other.
Good with 5. You know what, like with this, I'm actually not sure because or 7. It should be after that. I think they're 1 to 5. Oh, for that one. Well, you thought it was shoes. No, but like, oh, you divide it this way, 0.5, you get 0.32. What? Hold on a second, you just let it go. No, shit, no. Oh, hold on a second, no, it's 0.51. Yeah, that is not the correct thing. Yeah. But. Expands.
Yes.
You know what?
Uh-huh.
And that's 1, 2, 4, and then wait 7. Oh.
Oh, let me check that. Yes.
That is 2.3 feet. Well, if it's not. Did you get it?
No, I haven't even gotten to the page yet. I'm like, ah. There's our key. Okay.
That number is 3.
Okay. I get 0.12426. Uh-huh. Did you round somewhere?
Probably, but like here the problem, like like I'm putting into this calculator something by myself as well.
Yeah.
This cannot calculate like this.
No, mine can't either.
But it's still somehow that. Let's try.
So what I would do.
Zero point 5 and multiply by 0.
You can do x goes to m to your message, right?
All right.
So now you can use that number again if you want to.
Okay, 0. Number.
Yeah. Yeah.
oh, here is 1.70, whatever.
Yeah. Yeah.
And then I should divide this number by 1.7071.
Yeah.
Okay, cool. Yes, I had, yes.
think you have 1, 1. Yeah. That's me.
All right, never mind. Thank you. Sound right. All right, so like, you know, like I think. All right. Yeah. So what we're doing, we're just doing like example number 2 and example number 3.
Okay, we are going to be on page 100. Page 100. One hundred. So what we're going to do here is we're going to say, which way will it shift? And that will be, you're going to be given some concentrations, but you won't be given like just reactants. If you're given just reactants, obviously it has to shift to the products. If you're given just products, it has to shift to the reactants. But if I give you some products and some reactants, it could shift one way, it could shift the other way, and you need to be able to figure that out. And what we do for that is we use the reaction quotient. This is on page 100, 100. And the reaction quotient is identical to KEQ, except instead of using equilibrium concentrations, we use the initial concentrations. Okay, so for example, if this is our reaction here, KEQ is the equilibrium concentration of the products over the equilibrium concentration of the reactants, whereas Q, the reaction quotient, is the initial concentration of the products over the initial concentration of the reactants. You will hear this Q, this reaction quotient, referred to in many ways. Q can be called Ktrial. It's like you're trying out some numbers in the K to see, am I at equilibrium, or do I have too big of a number, or do I have too small of a number? Again, that's why you could also call it the trial KEQ, because you're trying out the numbers. Am I at equilibrium? Is it too small? Is it too big? Q is the Goldilocks of equilibrium. Do you guys know the Goldilocks story? Anyone not know the Goldilocks story? We all know Goldilocks. Okay. So we're looking for just right. Okay, we compare the values of Q and KEQ. Now, if Q is bigger than KEQ, what that means is that the ratio of products to reactants is it too big or is it too small? Q is bigger than KEQ. KEQ, if it were equal to KEQ, that would mean we were at equilibrium, okay? If Q is bigger than KEQ, what do we have too much of? Do we have too much product or do we have too much reactant? Q is bigger. So Q is too big. What makes this big? The top number or the bottom number? The bottom number? 1 over 8 is bigger than 1 over 4? No. What makes that number big? Products, okay? So that means we have too much product. Because this number is going to be big. Too big. Okay? Therefore, if we have too much product. Oh, hi. Sorry. I'm like off in la la land. Thank you.
I'm sorry, I'm just not.
Counselor said if you get a little thing, you got to go right now. I know. I'm sorry, Tayron. Okay. The system must shift to the, if we have too much product, the system is going to shift to the, if we got too much of this, it needs to shift left to produce more reactant until the ratio of product to reactant is equal to KEQ. Now, if Q is less than KEQ, that means Q is smaller. That means the ratio of products to reactants is too small. If it's too small, do we have too much product or not enough product? We have too much reactant, not enough product. If we have too much reactant and not enough product, we're going to have to shift to the right. The objective is always to get that ratio to equal KEQ. So we're going to shift to the right to produce more product until the ratio of product to reactant is equal to KEQ. If Q is equal to KEQ, that means the products to reactants ratio is just right. Using the Goldilocks analogy there. Okay? That means the system is already what? At equilibrium. Pardon me? Already at equilibrium. Okay, so let's do this example. Here we have our equilibrium. If you start with 4 molar, this is our initial. We don't have room for a whole ice table, nor are we actually going to do the whole ice table. But we start with 4 molar CH4. We have 2 molar C2H2 and 3 molar H2. In which direction will the reaction progress to reach equilibrium? Excuse me. So to solve this problem, you're going to calculate Q. could you please write the expression for Q? So all you do is you write what would be KEQ, except for you use your initial concentrations instead. Oh yeah, I missed a cube. Thank you. And then we just plug in our values. We plug in our initial values. Oh, thank you. I'm like, what have I done with it? Thank you. So now we have a value of Q. Q, which is 3.375, is bigger than KEQ, which we are told is 0.154. That means Q is,
What does at 2000 K mean?
huh?
What does at 2000 K mean?
At 2000 degrees, at 2000 Kelvin is the temperature. So you can just ignore it. So Q is too big. And remember, that means that concentration of products over concentration of reactants is too big. So we have too much product, not enough reactant. And if we have too much product, we can say, oh, look, I got too much product, not enough reactant. That means I'm going to need to shift to the left. The system will shift left to reach equilibrium. Is good? You don't have to write anything. You don't have to write any of this stuff here. That's just there by way of explanation. Yeah? But you should write all the rest of it. We're going to continue with this more next day. This is just an introduction to it. There's no homework attached to that. What is your homework this weekend?
Study for the quiz.
Study for the quiz and finish page 99. How are you going to study for the quiz?
Nothing. Just like we do the problem.
There's a ton of practice problems. right? Like, do as many as you need to. There's more than you need, probably. Don't neglect section 2.1, because that's also on there. Thank you.